Algebra lesson 4-8. We've dealt with a lot of different ways to graph so far. We've used input-output tables. We've used x and y intercepts. We've also introduced the idea of slope-intercept form, y equals mx plus b. And we've looked at different types of graph from the standpoint of vertical lines, horizontal lines, and diagonal lines. So we're kind of looking at all these different situations. We also talked in a previous chapter about functions. So we would like to take the functions and apply them to the graphs as well. Just like we were able to incorporate solving equations with graphs, there is some connection between the two. So when we talk about a relationship or a relation, it's an input that can have more than one output. Alright, so that's a situation. Anytime you stick a number in, it's possible that that number could have different types of outputs. Now, before we talked about functions, and that wasn't the case. If a number went in, it always produced the exact same number out. A number goes in, produces the exact same number out. This is not a function. This is a relation. However, it is possible that when you stick a number in, it always gets the same number as a result, as a function would. That could also be referred to as a relation because it's any set, which is another way of saying group, of ordered pairs. And certainly a function would have some ordered pairs. If we stick 5 in and we get 8, then we stick 6 in and we get 9, then we stick 7 in and we get 10. Those are creating inputs and outputs, which are really ordered pairs, so they're still going to be considered a relation. Now, if we want to know if we have a function or not, we can look at this right here, this vertical line test, which is kind of cool. If you hold your pencil or your finger up and down, it makes a vertical line, just like this pen is making a vertical line on the smartboard. Alright? A vertical line is not allowed to touch two different points at the same time, if it's actually a function. If you do the vertical line test and it ever touches more than one point, then it's not a function. But if you do the vertical line test and it only touches one point at a time, then it is a function. So let's try that out on this graph. Alright, I'll pull out a bigger vertical line, this meter stick. If I hold the meter stick here, it's okay right here. It's touching the green line in only one spot. But if I keep going, bzzz, 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 good, bzzz. Because if I hold the vertical line here, it actually touches the green line in 3 locations. It'll end up touching there, and there, and there. See? Bzzz. That is not a function. So this would be a relation. If we can't call it a function, then we'll call it a relation. Now let's try another one. So as we look at this one, vertical line, good, never touches more than one point of the graph the whole way. So we would call that a function because it passes the vertical line test. Now let's talk about y. If we talk about y, let's think about this location here has 3 different outputs. This coordinate right here is at -1, 7. This coordinate right here is at -1, -2. This dot right here is at -1, -9. You'll notice the x values are all -1, but it has different outputs, different y values. If a function has a number go in, it's always going to produce the exact same number out. In this case, when the number goes in, it produces 7. But another time the number went in, it produced -2. And then another time the -1 went in, it produced -9. That's not a function because it's producing different outputs for each of the same inputs. But over here, there's only one location for that value of x, and only one for that value of x, and that value of x, and that value of x, so it is a function. Alright, another vertical line test. Touches in 2 spots, touches in 2 spots. So it could be touching here, it could be touching here. That's not good. Bzzz, can't have that. So that is a relation. Alright, and another example. This is more similar to what we've been graphing, which if you notice, it never touches any more than one part of the red line at a time, which means it's passing the vertical line test. So that would be considered a function. So what if you're given an equation and it says, is the equation a function or not? Or is it a relation? You could make an input-output table and graph it. If it doesn't pass the vertical line test, then it must be a relation. If it does pass the vertical line test, then it's a function. All depends on whether it crosses more than one point at a time with your vertical line. All right, function notation. You might see this little funny f with an x inside the parentheses. You read that as f of x, and it's possible that there could be a g. So you might see g with an x, and that would be g of x. Or maybe it's h, or maybe it's r, or whatever it could be, different values, different variables. All right? It's just a fancy way of saying that there's a rule that's happening to the letter x. So when we say g of x, well, we'll use f of x. If we say f of x is equal to 2x plus 4, then what I'm saying is whatever x is going to get multiplied by 2 and then add 4. Okay, what if x is 7? Cool. Put 7 in. 7 times 2 is 14 plus 4 is 18. Yeah, but what if x is 3? 2 times 3 is 6. 6 plus 4 is 10. Whatever x is, a rule is being applied to it. In other words, this rule would be take x and multiply by 2. Then add 4. That would be the rule. That's what it's saying in algebraic expression. Those are the words for what we would do to x every single time. So this is just a fancy way of saying do something to x. And the something, in this case, was times 2 plus 4. Now that equation could be different. It could end up being negative 1x minus 2, or it could be just x plus 5. It could be anything. All right? I just want you to just imagine, though, this f of x is just like y. Y equals 2x plus 4, and f of x equals 2x plus 4 are exactly the same. The same. You don't actually have to do anything with the f of x. You plug numbers in for x, do the math, out pops your answer. You plug numbers in for x, do the math, out pops your answer. Exactly the same. All right? Now, our first example, I want to know if this is a function. And if it is a function, then we're going to state the domain and the range. If it's not a function, then we're not going to state the domain and the range. It would just be considered a relation otherwise. Okay? So here's the first scenario. You've got your in values, numbers that went into the function or relation, and then the out values. What was the result? Here, the number 4 went in and it became 0. Then the number 4 went in and it became 1. Here the 6 goes in and becomes 4, and the 8 goes in and becomes 4. So our question is this a function or not? One way we could tell is we could graph this. All right? I could come over here and I could say, there's 1, 2, 3, 4, 5, 6, 7, 8. And I could go 1, 2, 3, 4, 5, oops, too much on that one, 5, 6, 7. And we could graph these coordinates. 4, 0. 4, 0 would be right there. 4, 1 would be right there. 6, 4 would be right here. And 8, 4 would be right there. And if we have a graph, how do we tell if it is a function or not? We use the vertical line test. So if I take my vertical line and I go across, if it ever touches 2 points at a time, it's not a function. Bzzz. Good, 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 good. Bzzz. Good, 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 good. Bzzz. If it ever touches 2 points at a time, it's no good. This would be considered a relation, not a function. We can tell also from the table. The rule for a function is if 4 goes in, it better produce the exact same number each time. 4 goes in and makes 0, 4 goes in and makes 1. That's not the same value each time. Some people get caught up on the 6 and the 8, and they go, yeah, but the 6 is also... It's okay for the same, or for different inputs to produce the same output. That's okay. That's what this makes over here, which is going to be more horizontal. That passes the vertical line test. But if the same number goes in and produces different outputs, it'll produce like a vertical, which is no good. Alright? Now, this one I don't give you a graph. Let's see if we can figure it out. 1 goes in and it becomes 2. That's okay. 3 goes in and it becomes 4. That's okay. 5 also goes in and becomes 4. That's alright. It's okay for different inputs to produce the same output. 7 goes in and produces 6. So this would be a function. And if we had to state the domain would be all the inputs. 1, 3, 5, 7. And the range would be all the outputs. 2, 4, 6. State the domain and the range if it's a function. Alright, evaluate. Now, one of the most typical mistakes what I see when people are trying to evaluate, they think they're supposed to do something over here. We're going to say f of 4. In other words, remember f stands for a rule. Apply some rule to the number 4. Well, that rule is right here. Take it and multiply it by -3 and then add that to 7. 7 plus -3 times 4. 7 plus -12. -5. Don't do anything with this over here. You can just say f of 4. When a rule was applied to 4, the result was -5. So I plugged 4 in for x. I'm not going to divide by f or divide by 4 and try to get f alone. Don't do anything on this side. When the rule is applied to 4, it equals -5. Alright, try the rule again. This time the rule has changed. So we're going to say apply the rule to -2. 10 times -2 plus 3 means -20 plus 3 is -17. So when the rule was applied to -2, f of -2 equals -17. If you wanted coordinates for this, the coordinates for this would be -2, -17. Because if you recall, that is representing y. Y equals -17. The coordinates for up here would be 4, -5. Because our input was 4 and our output result was -5. Last problem. Graph f of x is equal to 5x minus 4. Well, f of x is really y. So this all becomes y equals 5x plus -4, because I'll change that to plus negative. And looks an awful lot like y equals mx plus b, which means that is our slope. So we go to our graph, and I'm going to put my y-intercept in -4. 1, 2, 3, 4. Y-intercept. And from that y-intercept, I'm going to go up 5 and right 1. 1, 2, 3, 4, 5, right 1. That's only 2. I can't really go up 5 and over 1 too easily now. But remember, 5 over 1, if you change one sign, you got to change the other. You could also go down. 1, 2, 3, 4, 5, and left 1. 1, 2, 3, 4, 5, and left 1. And there you have your graph. So function notation, function form where it's f of x, is really just the letter y. Do everything the same as before.